Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are talking about circle problems that have to do with the Pythagorean theorem. Let's get to it, shall we? All right, I think this is going to be pretty short, just one example. With circles and with line segments and chords and centers and diameters and radii, all that kind of thing, there are certain properties that are quite helpful to answer some mathematical questions. One of those properties is that anytime you form a triangle in a semicircle, then that triangle is a right triangle. Now, the important part is it has to be formed in the semicircle, meaning that the diameter of the circle must be part of the triangle. In fact, it will always be the hypotenuse in this case, because the right angle will be the vertex that is on the circle. Okay, so no matter where this is, it's going to be a right triangle. And let me just show you there. I have constructed a circle. Here's the diameter right here. And then I drew a triangle in it. And I can drag this point around to get all the different kinds of triangles. I can even go under here. And I can also move the diameter around anywhere. Okay. But what I want to do for you is just use the calculator to measure that angle, just to show you that it is indeed 90 degrees. So measurement, angle, and it wants to know what the angle is. Boom. This point, boom, boom. And you can see that it is 90 degrees. And no matter where the vertex is, it remains 90 degrees. And even if I go around up top, it remains 90 degrees. That angle is always 90 degrees, so that's always a right triangle. And no matter where the diameter is, look, I'm moving the diameter around. As long as the angle or an angle is actually the way the actual theorem reads is it's if an angle is inscribed in a semicircle, then it's a 90-degree angle. And all that means is the point is on the circle and the sides of the angles go to the diameter. But you can see how you can then also say that, oh, okay, well, that forms a right triangle if we include the diameter. Let's see if we can make the circle bigger. I don't think that we can. Nope. Okay. I can move the circle around, but we can't make it bigger. Oh, yeah, we can. There we go. No matter the size of the circle, it's always going to be 90 degrees. Move this around a little more. Okay. So I just have one fairly simple example to show you then. Let's get back to here. All right. A circle has diameter xy of length 13 centimeters. So let's go ahead and draw ourselves a circle here. Boom. Okay. And it has a diameter of length 13 centimeters. So let me draw a diameter here. Kind of estimating that. That looks about right. And we'll make the center right here. That seems about right. So we know that the diameter is 13. Z is a point on the circle, and the diameter is xy. Sorry about that. And Z is any point on the circle. Ready, stop. We'll put it right there. Okay. Such that xz is 5 centimeters. So I got to draw xz now. So from here to here. And they tell me it's 5 centimeters right here. I'll put that in here. Find the length of yz. So now I have to find the length of yz. Okay. And what we have done is we have formed an angle inside of a semicircle, so I know that it's a right angle. And with these three segments here, I have a right triangle. So I'm going to call this x, and that'll represent the length of yz. So using our friend Pythagoras, x squared plus 5 squared is equal to 13 squared. X squared plus 25 is equal to 169. If I subtract 25 from both sides, then 144 is equal to x squared and I take the square root of both sides. I get x equals the square root of 144, or x is equal to 12. Okay, so yz then is equal to 12. Let's see if there's anything else that I want to do here. We'll save that till next time. We'll make that a part 2. And that's it. Okay, so hopefully you enjoyed it. I know I did. And with that, I am out.